Python library is a collection of pre-written code, including functions, classes, and models that you can import into your Python program to perform specific tasks without writing the code from scratch. So we are going to be looking at NumPy and Pandas, as I mentioned earlier, and how they relate to each other. I want you to think of NumPy as a fancy calculator for numbers. Okay, it helps you store numbers in organized rows and columns like a grid or a table. You can do quick math with it, so you can add, subtract, find your average, or you can find patterns within your data. Okay, it is great with handling big numerical data. Okay, so we are talking about something like temperature, like prices, like stock values. Okay, so when it comes to pandas, now imagine NumPy is your calculator, right? But you want something like a spreadsheet. Okay, that's where pandas comes in. Okay, pandas is built on top of NumPy. Okay, think of NumPy's smarter cousin that speaks human-friendly language. NumPy gives speed in crunching numbers, while Pandas gives structure and flexibility. They often work together. Pandas stores data using NumPy's system under the hood. You can also use NumPy math functions within your Pandas data. Let's get into more practical examples, okay? Okay, so according to the environment you're working with, you'd want to install Pandas, NumPy and Pandas into your working environment. Okay, I'm sure you find so many videos on how to set up your working environment, but since we are using Google Colab today, I don't think you'd need to. But if you should be using an actual Jupyter notebook, I think you would have to. You should watch videos and set your environment to make things easier for you. Okay, so we are going to be importing a NumPy and Pandas library into our working environment. Okay. As you can see here, we have import. We use the word import, then NumPy, and then import Pandas. Okay. We use to avoid us repeating the word NumPy throughout or Pandas throughout our code. We use abbreviations, okay, shorter versions of the word, so that we wouldn't have to type out the whole word every time we need to use that particular library. So as you can see, we have import NumPy as NP and import Pandas as PD. So wherever in my code where you see me writing MP or PD, I'm referring to NumPy and Pandas respectively. Okay, so after we've imported our libraries, we have NumPy and Pandas within our working environment. I'm just going to run this to just run it into memory. Okay, creating array. We're going to learn how to create an array first. Okay, creating an array is very simple. Okay, we have a NumPy np dot, then the word an array, then your open brackets, and literally a list in there. So it's like you have your np.array, your open brackets, then your list in there. Okay, just like how we can have lists within lists, that's how an array can have an array within another an array. Okay, you can have a list within your list within your array. Okay, so when you have just one list creating your array, it's a one-dimensional array, okay? But when you have, according to the number of lists that go into your array, you have a two-dimensional array or a three-dimensional array. As we can see for our second example here, we have our first list created, so our first square brackets created, and within our square brackets we have two different square brackets in here, okay, which represents two different elements. So this would be one element and this would be another element, okay? But then, as you can see, we have one big bracket and two different elements within that bracket, okay? This is what we call a two-dimensional array, because we have just the initial list for the initial square brackets for our one-dimensional array, then extra square brackets in there for each element, okay? So we could have a three-dimensional array if we change one of these to let's say 3, let's say 5, okay? Now we have a three-dimensional array because we have the initial square brackets, then the second square bracket, then within the second we have a third square bracket within our second square bracket. So we have a 3D array here, but let's just keep it, for example, let's just keep it in 2D, okay? So as you can see, so yeah, writing an array is that easy. You just need NumPy and array. Let's run this and write our own example. Let me just add in here and write our own example. So let's go array 3, okay? And as I said before, NumPy, because that's the library we're going to be using to create this array, then array, then our open brackets, then the array we want to create. We're going to be creating just a one-dimensional array. So as square brackets, then our elements, okay? I'm just going to be going for 5, 6, and 7. So if I should reference my array, the way I should get my array, so that we get used to using print, I'm just going to be printing this out so that we literally just get the array there, okay? Okay, so let's move on to array properties. We are just going to be focusing on array properties that we use on a daily, array properties that we encounter very often when we are doing data analysis. The first property we are going to be looking at is dot shape. Dot shape helps us know the number of columns and rows within our array. I already wrote what it does in a comment right above it. So in this example, we reference our first array that we created, array 1, and we use dot shape to try to find the row and number of rows and columns. In this case, we are supposed to have an output of just 3 within a bracket followed by a comma, because it is a one-dimensional array and has 3 columns, column 1, 2, 3, but then it does not reference the fact that it has one row, but it gives us information about the columns because it's in just one dimension, it's just one row. So it just gives us the number of columns that it has. Okay, so let's run it. So yeah, we get 3 because it has 3 individual columns, but just one row, and doesn't reference the fact that it has one row. Okay, it tells us that we are working with an array with 3 columns. Okay, so the next property we are going to be looking at is dot ndim. ndim. Okay, this helps us know the number of dimensions our array has. Okay, so it helps us. It gives, let me just write, it gives the number of dimensions. Okay, so in this particular example, let me uncomment it. In this particular example, we are referencing our second array that we created with the variable name array2, and we use the ndim to find the number of dimensions that this particular array has. We are expected to see the answer to be 2 because, as we already learned before, because we have a list within a list within the array brackets over here, we can assume that it is a 2-dimensional array. So if I should run this, let me print it so that we'll have everything just showing up. Okay, let me just click shape, right? So shape 1, then print. Also dimensions, so ndim. Okay, and let me just run that there. So we have a dimension of 2 like we presumed earlier. So size, our next element we are looking at is size. Okay, size helps us know the total number of elements within our array. Okay, so each individual element, like 1, 2, 3 within our array, is what dot size is referencing. Okay, and here in this example, we are looking at array2 here. So it's going to tell us the number of individual elements. So element 1, element 2, element 2, 3, element 1 within our array. Okay, so let me just write what it does here. Gives the number of individual elements. Individual elements within our array. Okay, so let me print this too. So size, let me just bring this in here so that just makes more sense, right? Okay, do the same for the rest as well. So this one is oh yeah, like one. Okay, so we have a size of 4, right? Because we already know that the individual elements within array2 is 4, right? The last bit we are going to be looking at is D type. Okay, D type just refers to data type. Okay, so when you use dot D type, you want to know the data type your array is carrying. Okay, let's just write it here that D type helps us know the data type of our array. Okay, the data type of our array. Okay, in the example we are referencing array2 here, and we want to know the data type of our array. We already learned earlier the types of data, our data types, right? So it could be a string, it could be an integer, it could be a float, it could be, all these other data types. So by using d.d type to your array, it helps you know the number of the data type your array is, that particular array is carrying. So let's just run it to see our data type. This type is an integer here, as we can see in the example. Okay, so I'm just going to be brushing over slicing and indexing for the purpose of learning arrays. Okay, so here we can see that we've created this array, okay, ARR, and here we are trying to index, and you're trying to slice our array to just remove a certain group of elements that we want from the array. Okay, so when you're trying to slice your data or index your data, like before, you just reference your variable name of the array or your data you're working with. In this case is ARR, then your square brackets, the beginning point, the starting point of the data, the elements you want to extract, and the ending point of the elements you want to extract, excluding that particular index. Okay, so in this case we are trying to see that we are trying to extract the first the index number 1 through to index number 3, okay, excluding index number 4. So in this case you are supposed to be indexing from 20 up to 40, because as we know, in indexing we start counting from 0. Okay, so you have 0, 1, 2, 3, 4, right? So this 1 is referring to 20 because when you're counting your indexes, you start from 0, making 20 index number 1, and then with your ending point, it excludes the index that you have specified within your brackets. Okay, so in this case, instead of ending at index number 4, it ends at index number 3 because it is index number 4 exclusive. Okay, so we have it's counting from 20, 32 to 40 because you have index 1, 2, 3 as the elements that you want to index out of your array. Okay, and with your second, okay, so let me just and run it so that we'll see there. So we have 20, 30, 40 from our array. And I'm going to just comment that out and uncomment this one. When you see your array looking, your how do you call it, your slicing looking this empty, it's trying to just say that you want all your rows, all your columns. Okay, so for instance, let me just remove here, or rather let me specify what it actually means. So this example is trying to say from your array, let me make it comment, from array, I'm trying to get all my rows, all my columns, all my rows, and here is where you specify your steps. Okay, it's not necessary to specify your steps if it's not doing some kind of selective outputting. Okay, so if you're not selecting particular elements, it's not necessarily important to write the steps. Okay, in this case, when you see -1, it means that you want to start stepping from the last element. Okay, so in this case, -1 will be 50. Okay, but because it's a repetitive action that reads through the entire data set, our last element keeps changing. Okay, because after you have referenced your last element to 50 and you've taken 50, you take 50 out of your list. Now your last element is 40, then you take 40 out of your list, and now your last element is 30, take 30 out of your list, and last element is 20. So the output will seem like we flipped the data reading from the back to the front. Okay, so that's all this means. It's just saying that I want all my columns, I want all my rows, I want all my columns, I want all my rows, and I want you to step from the back. Okay, you could have put anything here. You could have put step of 1, a step of 2. In that case, it would jump 1 or 2 elements, then it will reproduce the next element that comes after. Then in this case, you are just reading from the back. So when we run this, we should get our elements 50 through to 10. Okay, there. Okay, so basic math, we are just going to be doing some basic math with our arrays. Okay, so in this example, we created array A and array B from random numbers. Okay, from the first array is from 1 to 3, and our second array, that's B, from 4 to 6. And we are going to be doing some basic math. Okay, we are just going to be adding A to B and multiplying, doing some square root and finding the mean. Okay, so when you're adding your array, you'd like to think of matrices in basic school. Okay, how you added your matrix. So your first element adds to the first element of the second array, and then your second element adds to the second element of your second array. So that's how it works. Okay, so when you are adding or subtracting, that is the ideology behind it. The multiplying to gives that same effect. Let me print them out. So here we are adding. Okay, here we are multiplying. So I'll just write multi, but why not, right? Okay, then here we're finding square root. There are so many commands that help make your life easy. NumPy has so many in relation to like mathematical problems, solving mathematical problems. Okay, and these tiny methods and functions make a coder's life easy, as you can see. So in this situation, I'll ask that you do a little research to see different kinds of methods and functions that you can use to perform mathematical equations within your code, like NumPy or math equation within your code. Okay, so I just want you to get a feel of it. So I personally don't even know all of it. I research it and find it when I need them. Okay, because you will definitely find it if you should look for it. Okay, you don't need to know it offhand. Okay, you can just search for it in Google and it will pop up. Okay, now we even have AI. We have ChatGPT. We have so many AI out there, so you could just ask it and it will tell you, and you could just use it in your code. Okay, it's not all of that. Okay, so yeah, to just let you know that you can perform basic math using your NumPy library. This is what you should expect